to another session that is part of the Inspiring IB Mathematics series. In this session, we'll be covering the core area of study, statistics and probability, for both mathematics, analysis and approaches, and applications and interpretation at the standard level. So this is really about getting started with statistics. When I'm working with statistics, I usually like to open up a new problem for each data set that I'm working with. That means I can call all of my data sets data and they won't confuse with one from another. So it also helps when you're working with exams that you open up a new problem for each question that you're working on, and then it's easy to find those problems by simply going Control and the up arrow. You can see all of the different problems you have. They're sometimes called problem 1, problem 2, problem 3. I've just renamed a couple of mine to show you that you can also rename them. Okay, so let's get back to where we were. So I have here a set of data from a hacky sack game between Jackie and Jasmine. They played 20 games and they counted how many times they were able to keep the hacky sack in the air before it hit the ground. So we open up a lists and spreadsheet page. If you're not sure, that's these pages here, the green. So lists and spreadsheet, nicely it lines up with Excel being green. So we have that green line there to tell us that we're in a a lists and spreadsheet page. So let's go across and start entering some of that data. So those first values were 1, 5, 24, etc. Now that's going to take a little while for me to fill in. So here's one I prepared earlier for us. So I've called this data set. So you'll notice here when I was putting the data in, up here it was just list A. But it's actually easier if you call your data set some word or even just 2 letters. Avoid single letters as your data names, but at least 2 letters. But this I'm calling my data set A. So now we can have a look down and you can see that those 20 results are all there and we can do our statistical calculations. In a lists and spreadsheet page, when we go to our menu, it's quite limited compared to what we see on a calculate page. But this is where we want to go, to statistics and stat calculations. We'll then do one variable statistics. So we click on that, we have one list, so we press enter. But now the advantage of having a name on my list means I can go here to this right arrow and open that and go to data A. My frequency of each of the values is 1 and it's going to put my results in column C. So I can press OK and here we have our data set. So we end up with our mean value, X bar, being 18.9, the sum of the X values being 378, the sum of the X values squared being 10,900. This is the unbiased estimate of the standard deviation. That's not required for standard level maths. So we move down to our population standard deviation, so our sigma X of 13.7. So this always for standard level, we're going to assume that the data set we have is the entirety of that population. So we use this 13.7. Those of you who also teach higher level, you'll be using SX, or the unbiased estimate, SN minus 1 of X, for some of those higher level questions. Okay, the number of pieces of data we had was 20. The minimum value, the least value was 1. Our first quartile is 6.5. Our median of 17, our upper quartile or Q3 is 27, and the highest value in the data set was 56. We then have this SSX, which if you hover on these ones, which is much easier on the computer software, but if you hover on it, it's showing us that it's the sum of the squares of the deviation from the mean for the data values. And that's 3,755.8. Okay, so we have a lot of information there that you can get depending on whether you would like information for a box plot or whether you would like the mean and the standard deviation. Okay. You can also do that calculation on a calculate page. So our calculate page is a grey icon here. So when we click on that, we get a grey bar up the top. So always the bar at the top tells us which page we're in. So we can also do that same statistics calculation, but you'll notice here when we go to our menu, we have a lot more options. And once again, in statistics, we have a lot more options. But here at Stat Calculations, it's exactly the same. So I can choose my one variable statistics. I can press OK. Once again, I can choose data A. And some of you that may have been watching very closely will notice that when it was in the lists and spreadsheet page, it had a little apostrophe here, whereas it doesn't in the calculate page. But still the same process again. So I choose my data list A, my frequency is 1, and I press OK. And here I have all that same information, but sometimes it's a lot easier to read on the calculate page. So you're able to see those values just a little bit easier, and you can see all of those decimal places as needed. Okay, so here we have the age of members playing pennant A, B and C grade hockey at a hockey club. So we can see their ages here from 23 through to 31 and the frequency of those players' ages. So this is a frequency table, and we can put a frequency table into our lists and spreadsheet. So you'll notice now I'm in problem 2. So I've already done that here. I've put those ages in one column and the frequencies in the other. And I've called my first list, list A, age, and my second list, list B, a shorthand version of frequency. Okay, so we can do the one variable statistics here, or we can do it on a calculate page. I'm just going to do it on a calculate page this time. Menu statistics, stat calculations, and I want number 1, one variable statistics. I have actually only one list of data, the ages. So click OK, and here I'll put in my age, but now in my frequency, I'm going to take my frequency list name. You can see that there were some other list names there for other lists that I've got ready to go. So now we press OK. And so the calculator has automatically combined that there were 15 people with an age of 23 and so on. So we can get that mean again, 25.1 to 3 significant figures. And the standard deviation that we want is the 1.95. There were 60 people in the club. The minimum age was 23. The maximum age was 31, and we can see that median was 25. Okay. So here I want to now talk about some of the different displays that we can get on our GDC. So this is the number of blue Smarties in 33 randomly selected 45-gram boxes. So we can see that a couple of boxes got up to 10 or 13 blue Smarties, whereas most had single digits and quite often quite low numbers. So I've put that data into a list, and this time I'm not going to find the one variable statistics straight away, because I'm sure you can work out how to do those now. What I'm going to do is have a look at the graph of these. So I'm going to open up this page here, the one that looks like a statistical plot, a bar chart. So I'm going to go there, and you can see there are loads of dots there. So down here it says click or enter to add variable. So just click down there and I can put my Smarties data in, and immediately it shows me a dot plot. So that's a really nice display for this type of data, where it is got a low range of values, so we can see it all in one go, and it's all integral values of those particular data values. So it's a really nice display, and we can immediately see that our mode value would be 4 Smarties. You could put that up and you could ask the students to estimate where the median and the mean is, and so you could have a little bit of an investigation with what happens if I change one value. So what does happen if I change one value? So if I were to change this 4 to a 14, and I go back to my graph, you'll see that that value has now appeared over here, and there's one less in the 4 column. So this is what we call the dynamic nature of our different applications, that they all talk to one another. So any changes I make here, so if I put that back to being a 4, I immediately see the change here. The other thing is, if I do my stack calculations and I do my one variable statistics of my Smarties data, there it is. If I now change this value, and we can see the mean is 5.212, if I change this value over here to 14, you'll see that that immediately changes the mean, and it will also change that standard deviation as well. So we can see that this is always working while you're doing these calculations, so you don't have to keep repeating the calculations. So that works in the spreadsheet. However, if I had done that calculation on a calculate page, I would have to actually do the calculation again. So let me show you that. The menu, statistics, stack calculations, one variable statistics, press OK, type in my Smarties. There it is. Now remember, this is with that change data value. So if I now change this back to 4, we can see that change straight away. But over here, there won't be a change. But what I can do is press the up arrow twice and press enter. So it's copied that down, and I press enter again, and you can see that I get the new value. So it's a little bit more work in the calculate page to see those changes. But once again, here's our graph. Okay, so the next, here we go. The next set of data I have is the expenditure of 40 randomly selected 16-year-olds expenditure per month in dollars. So some of these students are spending less than $100 in a month. Some are spending more than $100 in a month. Presumably they might be paying for their mobile phones or something like that. Who knows? But we've got this big list of data, 40 pieces of data. So once we get to that many pieces of data, a dot plot's not necessarily the best thing. The other thing is we don't necessarily have repeated values. We've got quite a range of values now. So if I go and put the data in, so here it is, all that I've called money, and you can go down to the bottom. If you want to get down to the bottom of a list quickly, you can press Control 1. It'll take you to the bottom value, and to get back up to the top is Control 7. Control 1 and Control 7 can get you to the top and the bottom of the list very quickly. So let's have a look at that. So down here, I'm going to click on my money, and there it is. It's just a bit of a higgledy-piggledy mess there, but that's not the type of graph I would like. This time I'm going to go to Menu and to Plot Type. And rather than do a dot plot, I'm going to do a histogram. By the way, the reason why dot plot was grayed out is because that's what it's already showing you. So you don't need to select that. But I'm going to choose a histogram. There we go. And that's quite nice, but it's not necessarily in widths that I would like. So I'm going to now change my widths of my bars in my histogram. And the way I do that is I go to Menu and to Plot Properties. And then I go to Histogram Properties and I go to Bin Settings. Now for all of the histograms in standard level maths, it will always be equal bin width. So let's choose that. And this time I'm going to choose a bin width of 5. And I'm going to put my alignment at 90. And there it is there. But because it was at 92, that starting value, I've now lost that value there. So if I go to Menu and Window Zoom and zoom for my data, okay, so Menu, Window Zoom, Zoom Data, here it is here. And we can nicely read those values off. And you'll notice that my little hand as it goes over is open there. And it's telling me that in the 90 to 95, there were 2 results. In the 95 to 100, there were 6 results. In the 105 to 110, there were 9 results. So that's quite handy as well. All right, the next thing I'd like to have a look at is some box plots. So here we have some ordered data of female and male reaction times when pressing a button that lights up. And this is in seconds. So we can have a look down here. There's a lot of data. I've already put it in order. That's not important, but it just makes it easier for putting it in here. So I've listed that, and once again, I've named my list female and male. So let's open up a data and statistics page with the pink border. And I'm going to go down here and I'm going to click on one of those data sets. So let's start with female because that was the first one listed. And once again, it tries to give me a dot plot, but I would really like a box plot. And there it is. And what I can see is that 2 of the data values were outliers. And if I come to here, it's 0.62, and it will tell me as I hover across all of my key values. So my 5-number summary is available here. Okay, and I can see that obviously my upper fence is somewhere between 0.62 and 0.67. because this is an outlier. So that's put that data set on. But if I would like my parallel data set, then what I can do is I can menu and plot properties, add an X variable. And I would like to add the male data. And you can see that I now have both data sets there. So notice that I said I added an X variable because they are both measuring the same thing, the reaction times, which were on my independent axis. And once again, I can have a look at my maximum value, my upper quartile, my median, my lower quartile, and my minimum value. And you can make comparisons accordingly. Looks like our upper whiskers are both about the same length, excluding the outliers. But that lower whisker here in the female data is much larger. The box is much larger. The median is higher for the females than the males. And the second quarter is much narrower, so much less spread. Okay. Here we now have some bivariate data. So data that connects in coordinate pairs. So I've got the age and corresponding salaries of employees at an accounting firm. So their age has been rounded to the nearest year and their salary is in thousands of dollars. So someone whose age rounds to 20 years is earning $55,000 a year and so on. So once again, I've put that data into my listens spreadsheet. I'm now going to have a look at what the scatter plot for this data will look like. So here's my data and statistics page. Down here, I'm going to put my independent variable, which I'm going to assume is their age, and it starts off looking like a dot plot. Then over here, on this y-axis, if you like, the dependent variable, I'm going to click and add salary. So now we can see our scatter plot. So the thing that we like to do with a scatter plot is, of course, put in a regression line, and we can do that on the screen here, or we can calculate our regression line on a calculate page. We can also calculate our regression line on a listen spreadsheet page. So 3 places we can do it. I'm going to start on the calculate page. So menu, statistics. It's a stat calculation, but this time it's linear regression. You'll notice there are 2 forms. It really doesn't make any difference which form. Statisticians quite often like the A plus BX because they like to start at the y-intercept. But a lot of times in the IB, we use the MX plus B form. Our X list was our age, our Y list was our salary. Now, the reason why I like the calculate page is because it tells me where it's going to save to. It's going to save as function number 1. That's because this is a brand new document and a brand new problem. So I haven't got any other graphs in my graph screen, but for students, they might have quite a few graphs in their graph screen. So this might come up as the next available one. So it could be something like F34. We don't need to change anything else, just the age and the salary, and we press OK. So it tells us the equation is in the form of mx plus b, where the m value is 2.51, the b value is 6.026, the coefficient of determination, which is not required for IB standard level maths, and then the correlation coefficient, Pearson's product moment correlation coefficient is 0.697. So this is moderately strong data. Now, I said it was handy because it was saved in F1. So what I can do here is I can do F1 of, and I can put in a value. So let's say we wanted to know the average salary of someone who is 42 years old. It's telling us that that person, according to that data set, would earn $111,000 per year. Okay, we could also solve for the other way around, but we tend not to do that statistically. So we have that. Now, getting back to the data and statistics page, what I said before was we could put the regression line on here. So if we go to menu, we can go to analyze graph, and you can see one of the things that's not grayed out is the regression. So we can show that linear regression on that page, and there it is there. And it's those same values that we saw before, 2.51x plus 6.03. So there it is there. So you can put that on and you can see that these data values very close to the regression line, these ones a little bit further away, and these ones here, well, they're in between, aren't they? So we can do that, but we can also open up a graph page. And remember, it was called F1 of X. So let's put in F1 of X, and there it is on our function page. So we can also see that line. And once again, you can do some calculations that you normally do on a function page. All right. This next example is also a bivariate data one, but the reason why I've included it, and this is specifically for applications and interpretation, is because they also need to know about Spearman's rank. So this is different to the Pearson's product moment correlation coefficient. We've got Spearman's rank correlation coefficient. And what it is for nonlinear relationship, which is monotonic, so either increasing or decreasing. So I've put that data in here, and I've also ranked it according to the Spearman's rank process, but we'll get to that in a moment. So what I've got here are all sorts of things. I'm going to put in my GNP data, gross national product data, and then I'm going to put in the life expectancy. So the key thing is that we often think the wealthier the country, the longer the life expectancy will be. And that pretty much is here, that as we increase in our GNP, our life expectancy has also increased, but this is clearly non-linear data. So doing a regression on this, oops, let me go back. If I just put in a calculate page and menu, statistics, stat calculations, and if I do the regression here, my X list of GNP and my Y list of life expectancy, we get an R value of 0.605. It's not that low, but when we look at the data, it doesn't look linear. Okay, so if I go back here, I've also ranked those for the Spearman's rank. So my lowest GNP value was back down here at number 1. It was also the lowest life expectancy value. But you can see that the 12th lowest GNP was only the 5th lowest life expectancy. And you'll see some decimals here as well. That's because that particular value for life expectancy was shared by two values. So it was the 22nd and the 23rd values were both 74. So we split those. All right. Let's have a look at the graph of those now. So I'm going to put in my rank GNP and my rank life expectancy. And you can see that looks much more linear. And so I can also put my regression line in for that and show linear regression. And there it is. And we can also do the calculation to see whether our R value has improved as Spearman's R value. So if I go menu statistics, stat calculations, linear regression, our rank GNP compared to our rank life expectancy, and you can see that's a vast improvement in the R value from 0.60 to 0.81. So we get a much stronger association when we have a look at the rankings as opposed to the actual data set. Okay, well, that is the end of that part of this presentation. What I'd also like to look at now are 3 investigations that I've developed and used in my classes to help students understand statistics a bit more. So these are ones on outliers and resistant statistics, understanding standard deviation, and the effect of changes on a data set. So for outliers and resistant statistics, let me just go here, and this is the little activity which will also be loaded up on the website. What I've got is my data set A, which is a set of data from 32 through to 39, and the students can very quickly see the median and they can see the mode, and with a little bit of a calculation we can find the mean. So we're going to find the mode, median, mean and range for these data sets. So that's the idea, and down the bottom here they can fill in a little table. The idea is to try and find out which of our statistics are not affected by outliers and which measures of centre are not affected by the outliers. So we have that. And what I do each time with the data set is this first one, I change one endpoint to be much larger. I change the other endpoint to be much lower. And then I change a few values at the upper end, which you could also have done a few values at the lower end. But the idea is for them to see how those changes happen. So if I go back to the calculator, I have entered the data in here. So then we can do that calculation over here. So our menu, statistics, our one variable statistics, and it's my data set A. This is a whole new document, so this is not the same data set as before. And I can see that my mean is 36.31. And if I go down, I can see that median is 37. If I now change the initial value from 32 to 2, we can see how that changes the values, but the median didn't change. So I can put that back to 32. And remember that control 1 will take me to the bottom of the data set. I can now change this data value to 99 and go control 1 to get back to the top, control 7 to get back to the top. And you can see that the mean has changed significantly. But if you go back down to the median, it's still there. Okay, so that's the idea of that little activity, and you're welcome to have a play with that. You can also adapt that to whatever would be suitable for your class, but it is a lovely way to use this dynamic nature of the spreadsheet. Okay, the next one, we go back over here, is about standard deviation. So one of the things that I find students really don't understand is what standard deviation is and what it tells us about the data set. So I get them to enter these 3 sets of data into their calculator. So what we find out is that for all 3 sets, the mean and the median are the same each time. But we can see that the data sets are not. So let's have a look at what that looks like. So here's the set of data for all of the 10s. And then I'm going to put in the next set of data. So let's call it, SD data 2. So notice that when I typed in SD data, it was bold because it thought it wanted to copy this, but by putting the number 2 there, goes, that's a whole new set of data. And so we can put in our new ones, 8, 9, 10, 11, and 12. And then I'm going to put in my third set of data, 3. Let me just find it. I better have another look. 7, 9, 10, 11, and 13. And so I press enter there. Let me just get there. 7, 9, 10, 11, and 13. So the data sets are not vastly different, but they are a little different. So I'm going to go over here and I'm going to do the menu, statistics, stack calculations, and our one variable statistics, but this time I'm going to use all 3 lists at once. And I press OK. So my X list, first one is SD data, then SD data 2, then SD data 3. And I put that in. And what I can see if I go across here is my one variable statistics for each of them. So we can see that that mean is 10, the sum of the values is 50, the sum of the X squared values is a bit different. But then if we get down to our standard deviation, the first one, of course, being all 10s was a 0 standard deviation. When they were all just 1 apart, we get that 1.414. Some people might recognise that as root 2. And when they were a little bit further apart, we got a standard deviation of 2. If we go down to the median, you'll see that they're all still 10s. Okay, so it's quite a nice investigation for having a look at what does that mean about our data set and what things do we need in order to describe our data. I'm just trying to get back up to the top there. So once again, I have some questions here that we can talk with the students about to get them to discuss and understand why we need standard deviation to help us describe data sets. And the last investigation I'd like to share with you is one about looking at the effects of doing the same thing to all values in a data set. For example, adding 100 to them or multiplying by 10. Now, the reason why I chose those numbers is because they're just easy numbers for the students to identify with. But you could use, add 3 to each number or multiply by 2. But I like to exaggerate things a little bit, which is why I'm using those powers of 10. Once again, I have a few questions here that we discuss with the students in order to get them to understand what has happened. But let's have a look at this data in the calculator. So this is problem number 3 now. Here's the original data. So I've got the data here, and what I can do is I can do, this can be the added data, and here I'm going to put in my added data equals. So all I did was press the enter button here. And what I'm going to do is put original data plus 100. And there are the values. So it automatically fills down for me. This one I'm going to call multiply. So I'll just call it mult. And here, by pressing the enter, I'm going to put original data and then multiplied by 10. And there it is there. So once again, we can get all the data sets up at once. Okay, so you can use that 3 lists, or you can work in a calculate page. You can also get the 3 lists, but it's not as easy to see, but just show you. Statistics, stat calculation, our one variable statistics, we can use all 3 lists. So we can put the original data, we can put the added data, we can put the multiplied data in, and here it is along here. So we have a little arrow to the side which tells us that there's more to see over here. So I can now scroll up and I can see that my mean was 12.2. Here it's 112.2. It's pretty easy for the kids to see that that is plus 100. And this one, 122, hopefully they can see that they've multiplied by 10. What we do see here when we added in our standard deviation, that we see no difference in the change in the standard deviation. So you can discuss that the fact that we've just shifted the whole data set up 100 hasn't changed the spread. But the standard deviation for the multiplied set of data has been multiplied by 10. Okay, well, that's all for this session.